We have equation on maximum likelihood estimation. And here, the equation says, given that x follows a normal distribution of theta and 1, find the maximum likelihood estimation of theta. Here, we have a known variance, and our variance is 1. So it's very simple for we to write the distribution. The distribution now becomes theta and 1 all over square root of 2 pi exponential xi minus theta all over 2. So this becomes the distribution because our variance is known. So for me to solve questions on maximum likelihood estimation, the first thing you do is to take the likelihood function. The second thing is to take the log, you differentiate and equate to 0. You get your answer. So the likelihood function of this is equal to the product n times of this function. If you take the product of this n times, you get 1 all over square root of 2 pi n and exponential, because you sum this n times 2 all over 2. So this is what we got. This is the likelihood function. The next thing to do is to take the log of this. We take the log of the function. But before we take the log of the function, it's best we arrange this to this form so that it will be easier to take the log. So this is still the same thing. Taking the log now, the log of the function, we have minus n all over 2 log 2 pi. If you take the log of an exponential function, you get that same thing. So you have summation of xi all over 2. The next thing is to take the differential of this. So if we differentiate, with respect to theta, we get, if we differentiate the whole of this function, we get 0. If we differentiate this, we get minus 2 summation xi minus theta 2 minus 1 all over this same 2. So, like we said, if we differentiate, we equate to 0. But we can bring this down, which implies that 2 summation xi minus theta all over 2 is equal to 0. So this can cancel this to give us summation of xi minus theta is equal to 0. So if you take the sum of this n times, you have summation of xi minus, if you take the sum of the constant, you have n theta, which is equal to 0. So summation of xi is equal to n theta if you bring this over to this side. So it means that our theta estimate will be equal to summation of xi all over n. And if you watch as this is our mean, this is mean, a sample mean. So we put it as this. So it means that theta is equal to the sample mean. So it means that the MLE of the mean parameter theta for a normal distribution with known variance is just simply the sample mean. This is how we can get this.